guys, so today we're going to be looking at section 3.1. This is out of our notes packet. What we're going to be starting to look at are critical numbers today. So just kind of looking up here at the top. So our goal is to be able to find critical numbers and absolute extrema over closed intervals. So critical numbers are going to be these places where we have possible maxes or mins. So remember, we've got extrema. Extrema means like anything that's an extreme point, like an absolute high point or a really low point. They're extremes. And so these critical numbers, that will be a possible extrema. So look at the definition here. So critical number, let f be defined as c. If f prime of c equals 0, or if f prime of c is undefined, then c is a critical number. Therefore, to find a critical number, take the derivative of the function, then set the derivative equal to 0 and solve. That x value is a critical number. Also, set the denominator, if there is one, of the derivative equal to 0 and solve. That x value is also a critical number. So let me just show you why here. So let's just have a little tiny graph here. Just kind of watch this. So if I have a graph that looks like this, can you see how the slope right here is positive, positive, but right there, that slope of that tangent line right there, can you see how that slope is going to be 0? Then we have all these negative slopes, negative, 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 but then right there, I'm just doing an approximation, right there, the equation of that tangent line or that rate of change is 0. And see how this is a high point relative to the points right around it. That's a high point. If we were on a roller coaster, we'd be going up the hill, get to the high point, down the hill, there's the low point, and then back up again. Okay? So we're going to find the critical number here. So that critical number is going to be when the slope is 0. So we want to know where that happens. So we do f prime of x equals 2x minus 10. And I'm going to take that derivative of 2x minus 10, and I'm going to set it equal to 0. And I'm going to get x equals 5. And so 5 is going to be a critical number. That's a place where we might have a maximum or we might have a minimum. Now, based off of your knowledge of parabolas, this is a parabola that opens up, okay? Remember how we find the vertex of a parabola? We can do negative b over 2a. What do we get? 5, right? Wouldn't that be the vertex? This would be a parabola that would open up. It'd have a vertex at 5 something. We'd have to plug back in to find that. So that makes sense that our critical number is at 5. All right, let's go over here now. So I'm going to find this derivative. Now, this derivative is going to be tougher to find because I'm going to have to use my product rule because this is a product. So I'm going to have to think of this as x times a quantity of 6 minus x to the 1/2. Now this has a restriction. It's just saying any x value we choose is going to be less than 6. And that's because if we go over 6, this would be an imaginary value. So that's the reason for that restriction. So anyway, we're going to do derivative of the first, which is 1, times the second, which is 6 minus x to the 1/2, plus the first, which is x. And then the derivative of the second part would be 1/2 times 6 minus x to the negative 1/2. But then we have to do times the derivative of the inside on that chain rule, so times negative 1. So putting that together then, I'm going to have 6 minus x to the 1/2. And this negative 1 is going to be there, so it's really going to be minus, and it's going to be a minus x over 2, and then 6 minus x to the 1/2. Okay, so now I'm going to set that equal to 0. So if I set that equal to 0, the easiest way to solve this might be to go ahead and take this over here. So doing that, I'm going to have 6 minus x to the 1/2 equals x over 2 times 6 minus x to the 1/2. Cross multiply now. X times 1, there's a 1 over there, is just going to give me x. And then 6 minus x to the 1/2 times 6 minus x to the 1/2. Well, when we're multiplying those, well, first of all, let's put the 2. But when we're multiplying a radical times a radical, the radical just goes away. So this would be just times 6 minus x. And so now we're going to have x equals 12 minus 2x. And I'm kind of running out of room, but if I take that 2x over there, I'm going to get 3x equals 12. And so this critical number, squeeze it in here, it's going to be at x equals 4. Okay? And then we just want to make sure that does meet that restriction. And yeah, it does, so we're good. Okay. Now we're going to look at absolute extrema. So over a closed interval from A to B. So a closed interval means instead of having that entire graph like I did last time, I did that kind of roller coaster, it's just a cubic function. Now we're going to have endpoints. So maybe we start here, we go up, we go down, and then maybe we go up here. Okay. Well, this point is a critical number, so it could be an absolute extrema. It could be the absolute highest point because that slope right there is 0. Here's another critical number. The slope right there is 0, so that could be an absolute minimum. But you can see when you even look at this picture, this point is actually the absolute max, right? Because it's the highest one of all of them. And this point does appear to be the absolute min. So out of all the possibilities, this could have been an extrema, this could have been, this could have been, this could have been. We had 4 possibilities. But what ends up happening is that this would be the absolute min, we'll just call it A min, and this would be the absolute max because it's the highest point. So let's keep reading and this will make sense. So over a closed interval from A to B, meaning from x equals A to x equals B, the absolute extrema occur either at the critical number or at the endpoints of the interval. Look, here's a critical number, here's a critical number, here are the endpoints. See how that could happen? To find absolute extrema, find the critical numbers. Plug the critical numbers into the original function. Plug the endpoints of the closed interval into the original function. Compare the outputs. The largest is the absolute max. The smallest is the absolute min. All right, let's do it. So looking at this one, I want to find my absolute extrema. So I need to find my critical numbers. Before I can do that, it's easiest here if I just distribute and make this an easier problem. So there's the problem. Now I'm going to take the derivative. And I'm going to set that derivative equal to 0. I'm going to have negative 2 equals 2x, so x equals negative 1. So I know then, based on this example, this little picture here, my highest point has to occur either at this critical number, or it has to occur at this endpoint or that endpoint. So absolute extreme is a little different. I'm going to plug negative 1 back into my original function. Here's my original function. Negative 1 squared is 1 plus negative 2. So I'm going to have 1 minus 2 when I plug that in, and that's negative 1. Now I'm going to have to plug in the endpoint, the a value. The a value right here is negative 3. So plugging that in, negative 3 squared is 9. 2 times negative 3 is negative 6, and I get 3. And now I'm finally going to have to plug in that b value, that 1 value. So I'm going to have 1 squared plus 2, and that's going to give me 3. All right, so what do we do now? Well, because we have 2 answers of 3, meaning we have an answer here of 3 and an answer here of 3, we are going to have an absolute max. It's occurring at 2 of those values, but it's still just going to be 3. 3 is the highest point we can possibly have. And then the absolute min is going to be negative 1. That's where that lowest y value that we have. So there's the absolute max 3, absolute min negative 1. Okay? And you could look at that parabola, on your graphing calculator, and you could see that pretty well, like why that happens. All right, let's do the same thing here, finding our absolute extrema. So I'm going to rewrite this function. Do you see how I could use the quotient rule, but the chain rule would be a lot easier. So I'm going to rewrite this as negative 2 times x minus 3 to the negative 1. That's just another name on how I can rewrite this. Because if I put this x minus 3 to the negative 1, that means it's in the denominator. And now all I have to do is use the chain rule. So f prime is going to be negative 2 times negative 1, which is 2, times x minus 3. Subtract 1, negative 2, times the derivative of the inside. Well, the derivative of that is just 1. So we're finished with our derivative. So I'm going to take this derivative and I'm going to set it equal to 0. And I'm going to go ahead and take the 2 doesn't go to the denominator, but the x minus 3 does. And I'm now going to cross multiply. Remember, that's just over 1. So I get 2 equals 0. Well, what does that mean? Well, what that tells us is that we have no critical numbers. Okay? So therefore, we're not going to have to check a critical number since we don't have one, but we are going to have to check the endpoints. So I'm going to have to compute f of 0. When I plug 0 in, I'm going to get, what, 2/3? And now I'm going to have to do f of 2. So that's going to give me negative 2 over 2 minus 3 is negative 1. So that's going to give me 2. So I'm going to have that's smaller, that's bigger. So I'm going to have an absolute min of 2/3 and an absolute max of 2. And if we were asked, like, at what x values those occur, then we would just have to say our absolute min occurs when x is 0. And our absolute max occurs when x is 2. And again, you could look at a graph on your graphing calculator and you could see that for yourself, that that is correct. Okay? Hopefully that made sense. If not, then just make sure you ask.